everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I'm here today with my second period class. Hi. They are super hyped because they have not been in a video in a while. So, all right, what we're going to learn about today is finding the opposite of the opposite and plotting rational numbers on a number line. So, I need you to first of all get out your bell ringer notebooks because we're going to go over this. We have to divide 1/2 and 3/4. So, what do I need to do this? Isaac. Drop, switch, flip it. Boom, boom. All right, so 1/2 divided by 3/4. These were already in the format we need, right? Just a numerator, denominator, no mixed numbers or whole numbers. So we are going to copy, dot, flip, switch, or keep, copy, dot, flip, keep, change, flip, or drop, switch, flip. So 1/2 times the reciprocal of 3/4, which is 4/3. You multiply those, you're going to get 2/3. All right? Who here got 2/3?
Wait, that's what you're supposed to say. I thought you were supposed to.
Now you could have, okay, so some people didn't simplify probably and got 4/6 and then they simplified.
Yeah.
I simplified before I multiplied. That way it saves you the step later, okay? So you can simplify it at the end when your numbers are bigger, or you can simplify it ahead of time before you multiply. Yes, if you didn't simplify, simplify it. All right, the next question is, what is the sum of 4.63 and 19.008? So what is the key when you're adding or subtracting decimals? Audrey?
Line them up.
Line up the decimals, yeah. So we just want to make sure we're adding the same place values with each other. So 19.008. Sum means we are doing what? Adding. Very good. All right, so there's not a number up here above the 8, so I'm just going to fill in a 0. I haven't changed the value of anything when I do that. So 0 plus 8 is? 3 plus 0 is? 6 plus 0 is? Bring down that decimal point. 4 plus 9 is? Carry your 1. You're going to get 23 and 638 thousandths. Very good. Any questions on that? All right, moving on. Let's go to your homework. I'm not sure which page you guys got to. You guys had 14 for homework. Did you finish 13 and everything? All right, very good. So we're going to go over what you had for homework, which was page 14. Did you guys take any notes about the opposite? Okay, so we'll do that here in a second. Yes, Destiny. All right, so your first question for your homework was to find the opposite of each number and describe its location on the number line. So what is the opposite of -5? Cheyenne? 5, very good. So I'm just going to write opposite above here so that we know what we're talking about. All right, so the opposite of -5 is 5. What's the opposite of 10? Very good. What's the opposite of -3? What's the opposite of 15?
-15.
Very good. So you guys also had to draw a number line for each of these. Who here drew a number line? Good. All right, so here's 0, right? Here's 5. Here's -5. You needed to plot each of those. Who can tell me about the distance? How far away from 0 is 5? Sydney? 5 units. How far away from 0 is -5?
5 units.
There you go. So this is kind of leading you up to absolute value because a number and its opposite are the same distance from 0 on a number line, just on opposite sides. All right, so -10, you could have counted by 10s, you could have counted by 5s here. It doesn't really make a difference as long as you are consistent. So we have 10 and -10 being plotted there. For 3, I would count by 1s. So 0, 1, 2, 3. Plot that 3, -1, -2, and -3. That goes right there. -15 and 15 is what needed to be plotted here. What would an appropriate scale be? What should we count by, essentially, is what that question is. All right. 5s would work. Very good. So let's do 5, 10, 15, -5, -10, -15, and plot 15 and -15 like that. Any questions on this? Isaac?
So what I did was I made like an entire number line for all of them, and
Yeah.
they all like ended at 15.
okay. That's really not what I wanted you to do. But that's okay. Write the opposite of each number and label the points on the number line. So this one, they combine all of these. So what is the opposite of 9? Destiny. -9. So right down here, you should have put a point at that intersection, and you should have labeled it a capital A. All right, point B, the opposite of -4. What's the opposite of -4? Aubrey.
4.
And that goes right here, and that should have been labeled with a capital B. Point C is the opposite of -7. Ben, what's the opposite of -7?
7.
Very good, and that would be labeled point C. Point D is the opposite of 0. Fancy business. What's the opposite of 0, Cheyenne?
0.
Very good, so that's point D. And point E, the opposite of 2, Tracker? Very good, and that was point E. Okay? It says, study the first example, write the integer that represents the opposite of each real-world situation, and words write the meaning of the opposite. So if we have a positive charge of 0, the opposite of that would be what? Negative charge, right? Which would be represented by what integer? What number? -7. Yep. So a deposit of 25, what's the opposite of depositing $25? Samaya? Yep, and that means we're doing what?
Withdrawing $25.
Very good, you two. So a withdrawal of $25, which would be represented by -25. All right. 3,500 feet below sea level, the opposite of that would be what? 3,500 feet above sea level. And that would be written as a positive 3,500. All right. A rise of 45 degrees, what's the opposite of that? A decrease or a drop, however you want to word that, a decrease of 45 degrees Celsius, and that would look like this as an integer. A loss of 13 pounds, this is just in time for the holidays. A gain of 13 pounds. LBs are that's the abbreviation for that. A gain of 13 pounds, so that's a positive 13. All right, on a number line, locate and label a credit of 38 and a debit for the same amount. So I'm just going to use this line that they gave right here as the positive 38 and this as the negative 38. The positive 38, is that the debit or the credit? It's what?
Credit.
Credit, very good. So above the positive 38, I want you to write the word credit. Above negative 38, I'm going to write what word? Debit. That means money coming out of your account. A credit is money going into your account. 0 would be what? Audrey. I don't know if the mic picked up your excitement over that. Oh, the starting balance. All right, so that's what you started with. What questions do you have so far? You're good with this? All right, let's move on. On a number line, locate and label 40 degrees below 0 and 40 above 0. What does 0 represent in this? In this situation, I think it says. All right, so this is just a goof up there with the printing. So that would be 0. What should we count by? Josh?
20s.
20s will work. Very good. So 20, 40. Here's 40 above 0. Here's negative 20. Here's negative 40. So that's 40 below 0. What does 0 represent? Josh?
Freezing point.
Very good. The freezing point of water. So let's just label that freezing point. All right, any questions at all? All right, so I'm going to quickly rapid fire some integers at you. I want you to quickly say the opposite. Ready? -5.
5.
-28.
28. 20.
32.
Negative 32.
57.
Negative 57.
Negative 1 million.
1 million.
Negative 2.5.
2.5.
All right, there's no fooling you. Let's see if I can get you on this one. What is the opposite of the opposite? Most ridiculous question ever. What is the opposite of 10?
10.
All right, you got it. So I want to bring up too to you guys that the people, like you guys all understand opposites well. You all understand opposite of the opposite is the original number. There's nothing really complicated about any of that. What will separate the people who get questions about that right and the people who get questions about that wrong is who is reading carefully, who is underlining the keywords, because your brain will go into autocorrect mode and it will think that oh, this person must have typed the same thing twice, and your brain kind of almost corrects it. You know what I'm saying? So you're going to have to be really intentional when you're reading stuff to underline, make sure you've read it twice, because kids miss that type of question all the time, and it's just because they didn't read carefully. You know, it's not because they don't know the concept. Anyway, we're going to move on to rational numbers on the number line, so we're going to skip that page. We're going to go to lesson 6, to the opening exercise. All right, so the first thing we're going to do is work on writing down equivalent numbers. So this is a little bit of a throwback to things we've already done. So if we have the number 1/2, that's a fraction, right? What is 1/2 as a decimal? 1/2 as a decimal. Sid?
0.5.
0.5. Very good. Does anyone know where we get that answer? Yes. Go ahead, Audrey.
1/2 is half of 1, and 0.5 is also half of 1.
That's true, but let's say we have one that's not so easy. You know, how would we turn any fraction into a decimal? Go ahead.
We divide the numerator by the denominator.
Very good. So if you're ever in a situation where it's not one that you know, you take the top number, the numerator, that goes into the inside here of the gazinta. Remember, that's the one that's getting operated on, divided by our divisor, 2. All right? We're going to then have to put a decimal in zeros probably. 2 goes into 1, 0 times. Bring up that decimal point. 2 goes into 10, 5 times. That's going to give you 5/10. All right? 4/5, you can do it the same way. So which one goes into the gazinta? 4. Very good. And 5 is our divisor. So 5 does not go into 4. You have to add a decimal and a 0. And keep doing that until you get something that finally terminates. Or if you figure out it doesn't terminate, you put the little repeating bar. But that's not the case with this one. 5 goes into 40 how many times? 8 times. Yep, and that's going to give you 40. You're going to get 0, so you are done here. So this is the same thing as saying 8/10. 4/5 and 8/10. Where would they be in relation to each other on the number line? Isaac? Audrey?
Wouldn't they be negative?
No. If I plotted 1/2 on a number line and 0.5 on the number line, let's say, here's 0, here's 1, here's 1/2, right? Where would 0.5 go?
On 1/2.
It would go where, Josh?
On 1/2.
On 1/2. It's the same number. They're equivalent. So it goes in the same spot, okay? So that's really the concept that you're learning right now, okay? They have the same equivalency, or the same value. They're equivalent. They are going to be in the same spot. So we have 6 and 7/10, so your whole number is going to be 6. Now, this one has one of those magical denominators that's a power of 10. So that makes life really easy when it's a power of 10, because then you don't have to do any division, really. You can just say 7/10. You would read 7/10 as a fraction like that, but you'd also read this as 7/10 as well, right? So 6 and 7/10. Any questions on that? All right, the next one, write the fraction equivalent of each decimal. So going the opposite direction here in process. Instead of converting it from a fraction to a decimal, how do I turn 0.42 into a fraction? How would I read that number? Let's start there. How would I read that number, Isaac?
0.42.
Okay, well that's kind of a, non-mathematical way. I know I do it all the time, but that's for time saving purposes. Samaya.
0 and 42 hundredths.
Very good. So can I write 42 hundredths as a fraction? Yeah. How would I write that as a fraction?
42.
Sorry, Cheyenne?
42.
Very good. 42 over 100. Then we can simplify, right? They're both what type of number? Even, which means they're both divisible by 2. Yeah, so if you take 42 divided by 2, you're going to get 21. And 100 divided by 2 is, do they share any other common factors other than 1? No, they don't, because I'm thinking of 3 and 7, neither of which are factors of 50. All right, let's go ahead and do the next one. We have 3 and 75 hundredths, so your whole number is going to be 3. How would I write 75 hundredths as a fraction? Not everyone at once. Micah?
75 over 100.
Very good. 75 over 100. Can that be simplified? Yes, it can. What are 75 and 100 both divisible by? What's their GCF, greatest common factor, Micah? 25. So 75 divided by 25 is 3. And 100 divided by 25 is 4. Yep, so we're going to get 3 and 3/4. All right, the next one looks, it's going to be really difficult. So we have 36 as our whole number. How would I write that decimal as a fraction? Audrey? 9/10. You already simplified, right? So you would read this 90 hundredths, but as you can see, we're going to have that extra 0 here we can chop off. And when you have a 0 on each one, you're essentially dividing by 10, right? So you have 36 and 9/10. Nice job. Any questions on that? All right, so that's a little review. Let's go to the next page, page 17. All right, locate and graph the number 3/10 and its opposite on a number line. Well, what is the opposite of 3/10? Negative 3/10, yeah. So we need to plot both of those on here. So we've got to plot this and this. Now, how am I going to plot 3/10 on here? What do I need to do with this? Anyone know? Can I plot fractions on a number line? Yeah, so I'm just going to have to, Tracker's already doing it. Tracker, what are you doing there, bud?
Just writing 10, putting in 10 lines. Because the denominator is 10.
Very good, perfect. So he just said he's making 10 sections here because the denominator is 10. So you need to do the same thing. So this first section would be 1/10. The second one would be what? 2/10, or we could say 1/5, right? This would be 3/10, 4/10. This would be 5/10, or what? 1/2, good. This would be 6/10, 7/10, 8/10, and 9/10. And this is where I become very proud of my ability to fairly evenly space those. I know, kids. Be jealous. All right, just kidding. So 3/10 would go right here. Right, so we can plot numbers that are fractions. We can plot numbers that are decimals. I kind of think of it like when you're using a phone and you kind of can pinch your fingers together to make something bigger, or no, you're zooming out, I'll say. And if you go like this, you can't see what I'm doing at home, but if you kind of spread your fingers apart, you are zooming in, right? So we're kind of zooming in here. These are the sections of the number line you didn't know were there. All right, let's do the opposite side here. So -1/10, -2/10, -3/10, -4/10, -5/10, -6/10, -7/10, -8/10, and -9/10. All right, and the opposite of 3/10, Ari said, was -3/10, so that's going to go right there. All right, so pretty straightforward. The next section kind of divides up the lines for you. That's nice. Use what you know about the points -7/4 and its opposite to graph both points on the number line below. The fraction -7/4 is located between which two consecutive integers? Explain your reasoning. All right, so we've got to decide what we're dividing this into. So Tracker said last time he divided it into 10, bless you, oh, that was a cough, 10 sections because that was the denominator, right? So what do you think we would use for this one? What's the denominator of that fraction? 4. So let's use sections that are fourths. So I'm going to make that middle one 0. So this would be 1/4, right? This would be 2/4, otherwise known as 1/2. Right? This would be 3/4. What would this next one be? It would be 4/4 or 1, right? So we could write these different ways. This would be 1 1/4, which would be how many fourths? 4/4 is 1. So it would be 5/4 or 1 1/4, which is, we can write under here if you want to, 5/4. This would be 1 1/2 or 1 2/4, right? Which is the same as saying how many fourths? 6/4. And then the next one would be 1 3/4, which would be how many fourths, guys? 7. Yeah, so 7/4. And then this would be what number right here? 2. All right, so if we were plotting -7/4 and its opposite, well, we've got to do the other side here too. So just go ahead and put negative signs and go the opposite direction here on the left of 0. All right, so you should have each side down. Now you guys remember converting improper fractions into mixed numbers. That's essentially what we're doing here, right? 7 divided by 4 is going to give you 1 whole with how many left over? 3, yep, so 7 divided by 4 equals 7 being divided by 4. That's going to give you 1, and you're going to end up with 3 over 4. Yep, so 1 3/4. So -7/4 would be -1 3/4. So plot one here, and then the opposite of that would be +1 3/4. All right. Now it says the fraction -7/4. So we're looking at this one down here to the left. Is located between which two consecutive integers? Remember, integers are what type of numbers? Whole numbers. Yeah. So what is -1 3/4 between? What two whole numbers? Aubrey.
1 and...
Nope. 1's down here to the right. -1 and... You're saying it's between this area right here?
No.
Okay, then let's take that back.
-1 and 0.
You're saying it's right here? Between here and here?
Oh, no, -2 and -1.
Between -1 and -2. All right, so it's between this number and this number, right? Do you guys see that? It's right here. Okay, so on the number line, each segment will have an equal length of, what did we count by here? What was our scale? 1/4. Very good. The fraction is located between what again, Aubrey? between -1 and -2. Any questions on that? All right, we're going to call it quits on that page right at the moment. We'll come back to the rest of this tomorrow. Tonight your homework's going to be on plotting a number and its opposite on the number line. So I'd like to thank you guys for watching. Don't forget to hit the like button. And if you haven't already subscribed, please do so. Thanks a lot.
Bye.